mode of transfer of heat in which heat travels in the form of rays, right now, and heat travels in the form of rays in all the directions. Okay, and a medium is not necessary. A medium is not required for the transfer of heat in this. Getting it? And these waves can move through the vacuum also. Hey Salman, how are you? Getting it, guys, everyone? So radiation is a transfer of heat in the form of waves for which a medium is not required. These waves can move through the vacuum also. Also, saying that a medium is not required, so it means that even if a medium would be present, then also radiation will occur. But even if a medium is not present, so obviously there also medium radiation will take place. So that's the thing. Okay. Further, we also have learned that radiation is emitted by all the bodies, right? Our body also emits out some amount of heat, right? And that heat emitted out from our body is basically radiation coming out from our body. Okay, now then the amount of heat released from a body, basically the radiations given out by the body, will depend upon different factors. Getting it? It will depend upon different factors. Like it will depend upon the color of the object, the texture of the surface of the object. Yeah, Sam. Then the surface temperature and the surface area of the object. Like for example, we know that objects like which have a lighter color and which have a darker color, right now. So objects having light and dark color object, I'm to say that objects having light or dark color will be emitting different radiation. Okay, now will be emitting out different amount of radiation. Like we know that dark materials, okay, now darker metals tend to absorb more amount of radiation, right now they tend to absorb more amount of radiation, while lighter clothes, objects made up of lighter color, tend to absorb little amount of radiation, then they give out little radiation. Okay, now we have this we had this question in the last test: why does a cup of hot tea become cold after some time, even if it is not in direct physical contact with some other object? So it is due to the radiation of heat in all the directions. The cup of tea becomes cold after some time. Okay. Further, there are applications of radiation in our daily life, right? Now, there are application of radiation heat in our daily life, radiation in our daily life, right? Now, like the microwave oven, how does it work? It uses the radiation to heat the food. Now, getting it, everyone? It uses their in stoves, the burner on the stove and the heating elements that is used in making the oven. They also emit radiation which heats the cookware and then heats the food, right? Then the sun's energy coming to the earth is also via radiation. Now the sunlight comes to the earth via radiation, in the form of radiation basically, and it heats the earth's surface and warms our planet earth. Solar panels, they absorb the sunlight and convert it into electricity through the principle of radiation only. So there are so many applications of radiation in our daily life. There are solar heaters also. They are designed to use the heat energy from the sun for cooking food. Right now, solar cooker, you guys understand, you know about solar heaters?
Yes.
Food can be cooked with the sun's heat also. There are special solar cookers. Let me show some examples, show some images to you guys. Okay, even we can make it at home if we have the necessary equipment. And you know, sun's heat, like it has so much of energy in it, like it can even be used to burn down things. Getting it? Like it can be used to burn down things also. It is sunlight has so much of energy, you know, that you can use that energy to burn a piece of rock. Getting it, Ayush, Salman, and Halima? So solar
Yes.
heater. I'm looking for an image of solar heater. Hold on. Okay, this one is the relevant image that we can look at. Okay, look at this. Look at this. See, what is going to happen the sun's rays are going to fall on this antenna, on this disc shape. Okay, and all of that is concentrated at this point. All of them are concentrated at this point. Let me show it over here. These are the sun's rays that falls on it. Okay, now, and after falling, they will get reflected now, and they will, after reflection, they will come to meet at a point like this. These are the incoming sunlight that falls onto the mirror. By the way, this is basically having glass mirror on it. So after reflection from the glass mirror, they come to meet at a point. Getting it, everyone? No, they come to meet at a point.
Yes.
Okay, so where they meet, so much of energy is being concentrated at a point, and you can see a cooking utensil has actually been put here, right? And due to the heat, the food inside it will be cooked, right? So that is an application of radiation now. Via radiation only. Radiation is the mode of transfer of heat of the sun. Sun's heat energy is coming to the earth via radiation only. Then we have example of this also, like we prefer wearing light colored clothes in summer because light colors are poor absorbers of heat. They don't absorb that much of heat. On the other hand, we prefer wearing dark colored clothes in the winter because they're good absorbers of heat. They absorb the heat from the surrounding and keep you warm. Okay, no? And they keep us warm. That's the thing. So these are some of the applications. Let me write down some other applications also. Okay, no? So thereby we also have the examples. Third example you can take as microwave ovens. Microwave ovens, they also use a form of radiation in order to heat the food,
Yes.
cook the food basically. Fourth one, we can take the example of solar panels also. Do you guys have solar panels at home? Yeah.
Yes, sir. I do.
Yeah, I also have solar panels, right? Good. Now, you guys know about the radiator of a car? Like there's a radiator in front of the car engine that helps in keeping the engine cool. It takes away the heat, good. Have you ever wondered like why the radiator is always painted black? Why the radiator of the car is painted black? Mhm. Why so? Because the
Because it absorbs the heat.
exactly, right now, because black colored objects are good absorbers of heat, right? So it is located just near the engine now. Here is the engine. Look at this. This is the engine, and just in front of the engine, we have this radiator installed over here. So what the radiator would be doing, since it is black in color, so it absorbs more amount of heat from the engine. It will absorb the heat from the engine, and it will radiate
Yeah.
it back into the environment. Like from the front part of the car, those heat will be released into the environment. Just behind this, the engine is situated. Just behind this. So from the engine, it will be absorbing the heat. Heat is absorbed. Okay, so it will be efficiently, like painting it black enhances its ability to absorb the heat from the engine and radiate it. Basically, it is being radiated. Okay, now, and hence cools the engine, keeps the engine cool. So that is the thing. Okay, Halima, read the given paragraph.
Black surfaces are the best absorbers as well as best emitters of heat. As radiators are heat exchangers used for cooling engines. They are painted with carbon black or aluminium to cool the engines efficiently.
Right. Black surfaces are the best absorbers as well as best emitters. Like they are good at absorbing the heat, plus good at releasing the heat also. Okay, now. So thereby, the radiators, as we know, that they are used for cooling the engines now. So hence they are painted black, right, or with carbon black or aluminum color to cool the engines efficiently. So that's the thing. Now we have a few topics left to be discussed. Like we'll be learning about the working of this thermos flask. We all have a thermos flask at home. We know we use it to keep the liquids like coffee or tea or juices warm or cold for a longer duration of time. But ever wondered like how exactly does it work? So that is what we're going to understand. Okay. The use of thermos flask, we know that it is to maintain the temperature of liquids that is kept inside it. Keeps the hot liquids hot or cold liquids cold for a longer period of time. Let us understand the working of it. Okay, na? Here is the breakdown of the typical structure of a thermos flask. Okay, so that is the structure of a thermos flask. Let us understand its working. Okay, look over here. That there are two casing of this. There are two walls of this. Okay, na? How many? There are two walls. The outer one and the inner one. Getting it even the outer one and the inner one. Okay. Further, between the two walls, there's a vacuum. Between this wall, let me highlight it over here. Between this wall, okay, and between this wall, there is vacuum. Let me highlight it with the green color. So the green color portion means there is vacuum. Got it, everyone? That is vacuum. That's vacuum. Okay. Now the inner wall of the flask is silvered wall container. Has a silver, like there's a coating of silver, or usually we use aluminum to coat the inner wall, or like sometimes stainless steel also is usually commonly being used. Getting it? So now let us understand how basically this thing is working here. How this thing is basically being working over here. So the first thing we are seeing that the inner wall is basically having a coating of silver. Sometimes there's a thin coating of silver, or usually a what do we say? Stainless steel is used. Getting it now? So how does that help in keeping it cool? How does having a silvered inner wall in this flask help in keeping it cool or hot? Getting it? So we know that basically, if suppose we have taken hot coffee inside this, we know that it can be kept hot for like 7 to 8 hours or more than that. If we have cold coffee, it can be
Yes,
maintained at the same temperature for a longer duration of time. Okay. We know that heat travels from one place to another via three different modes. What are that? What is that? What are the three different modes via which heat?
cooling,
I'm saying what are the different ways, different modes of transfer of heat from one place to another?
heat,
Uh-huh. Conduction, convection, and radiation, isn't it?
yes, sir.
That's it, no? Conduction, convection, and radiation. Okay.
Yeah.
So if we somehow stop the flow of heat or limit these things over here, if we limit conduction, convection, and radiation in this, so will we not be able to keep it hot or cold for longer duration of time? Tell me.
Sir, we will
Getting it?
check.
Okay, now see. Okay. So it has a double wall. It has a two walls construction over here. Usually it is made up of metals, and there's a vacuum between them. Now the space between the wall here, that is filled with vacuum. So vacuum, we know it's a poor conductor of heat now, right? So vacuum here will reduce the loss of heat via conduction. Vacuum, it we know vacuum is a poor conductor of heat. Hence, because of this, it reduces heat transfer by conduction and by convection also. Hence, it reduces heat transfer via conduction and convection. That basically means that heat cannot the heat cannot go from the hot coffee to the outer environment via conduction and convection, because the layer between the two walls is basically air from this has been evacuated. There's a vacuum between them, and vacuum is a poor conductor of heat now, because of which it will reduce the transfer of heat from the hot coffee to the outside via conduction by conduction and convection. Tell me if that much is clear to everyone or not.
Yes, sir.
Okay. But you know that radiation does not need a medium. It can occur via vacuum also. But the
Yeah.
the silvered inner wall of the flask, now it is made up of silver, so it will reflect the heat back into the coffee or some other liquid. Let us suppose that the heat is trying to escape, but it gets reflected back. Let me use some other color. Say that this is the heat. It tries to escape from here, but due to the silvered inner wall, it is reflected back into the given liquid over here. Got it, everyone? So hence,
Yes, sir.
radiation is also being limited here. It minimizes the heat transfer by radiation also. So the inner surface of the outer wall and the outer surface of the inner wall are both silvered. Let me write about that also. The silvered surfaces. The inner surface of the wall is basically silvered, has a thin coat of silver on it, has a silver. You know, that's why like these flasks is quite expensive. That is one of the reason why it is quite expensive. If suppose you have to get a 1 liter of thermos flask, the one that actually works, not the local one, so that will cost you somewhere around 1,000 to 1,500 rupees in India. That's the price here in India. Getting it? Because silver is used here, plus better technologies are used in this. So the inner surface of the wall is silvered, and it will basically reflect heat back into the flask, minimizing heat transfer by radiation. Hope that much should be clear to everyone. Okay. Now further, a cork or a plastic cap is also used here. Plastic stopper is also used here. Like this is the cap over here. That is also used to further reduce heat loss through convection by sealing the opening of the flask here, right now. Getting it? Heat can be lost if this is open. So basically the stopper is used here. That is the thing. So this is how it basically works. We minimize the heat transfer through different methods. A thermos flask will be effectively keeping the content of the flask at the desired temperature for a good period of time, for a good amount of time. Hope that much should have been clear. Any questions? So that was the working of a thermos flask, right? So it has vacuum, it has silver surfaces, plus it has a stopper also. Stopper, basically a cap or cork can be used here. Okay. So one of you please read the given paragraph. Do one thing, Salman, you read the paragraph till here. From here till here, you read this. Next, Ayush, you'll be reading from here till here. Yeah, fast.
Of a thermos flask. A thermos flask is used to maintain the temperature of liquids kept in it. It keeps hot or cold liquids.
Okay, Halima, you continue.
A thermos flask is used to maintain the temperature of liquid kept in it. It keeps hot liquids hot or cold liquids cold for a longer time. The outer casing of a thermos flask is made up of plastic which acts as an insulator, preventing the heat loss through conduction. Inside it is a double-walled container made of glass or stainless steel.
Okay, Ayush, you continue.
Sir,
From where I pointed.
From here, both the walls.
So both the walls are polished, so they are shiny. The place between the two walls is vacuum. The prevented loss through convection. The shiny surface of the walls prevent heat loss radiation.
Okay, so this will be preventing heat loss through convection. Okay, and the shiny surface of the wall also prevents heat loss through radiation. Right. So here we have learned the vacuum helps in minimizing the loss of heat via conduction and convection, and having the sulfur surface. Yeah, Salman.
sir, sorry, I left by internet problem.
Okay, no worries, no worries. Okay. By the way, Ayush, why your voice is not coming properly? Like it, um, it's very low, like kind of inaudible. You're almost inaudible. Okay. Now, next topic is kind of clothes we wear in winter and summer. So obviously, known white clothes we usually prefer to wear in the summer. Why? Because it reflects the sunlight. Yeah, Ayush, you're saying something?
So the candidates elaborated thermometer.
I really cannot understand what you're saying because your voice is breaking a lot. Please type it in the chat box. What's that? Islamic treasures, Halima? Okay, see. Pay attention here, everyone.
So I would say we elaborated thermometer at home.
Can we? Can we what?
Can we make laboratory thermometer at home?
Ayush, type it in the chat box. Please type it in the chat box. I cannot understand what you're saying. Please type it there. Okay. Next topic is kind of clothes we wear in winter and summer. Right now, so how it is related to the color and how like it is related to the heat absorption. Okay. See, basically we know that the light colored objects are better reflected of heat. They reflect the heat. While dark colored objects, they are good absorbers of heat. Right. So the amount of heat which an object can absorb by radiation particularly. Right now here the concept of radiation is being involved depends on the color of the object. So the objects having dark color object having dark colors absorbs more heat radiations than the objects having light colors. Okay, no? So that is the thing. Even we can perform some activity to do this to understand this. Okay. So what we can do basically also one more thing is that the amount of heat which an object can give out by radiation that also depends on the color of the object. So having hot objects having dark colors emits more heat radiations than the objects having light colored. Okay, no? So that is the thing. Okay. Also, there is importance of color of objects in everyday life. Right now, we use dark colored objects where we want to absorb more heat, and light colored objects where less heat is desired. Like people prefer to wear white clothes or light colored clothes in the hot summer days because white clothes or simply light colored clothes they absorb less heat from the sun. In fact, we know. In fact, the white clothes or light colored clothes, it reflects most of the sun's heat rays which falls on them. Right now, most of the sun's heat rays are reflected by them. Okay, that's the thing. But also you would see that people who used to prefer who prefer to wear dark color clothes like even in the summer season so they would be sweating a lot, they would be sweating more in comparison to other, getting it, no? That's the thing. Further, color of houses also is determined by this concept. The houses in the hot or sunny countries like ours, like India is a hot country right now, They are usually painted white or with light colors from outside. Why usually the houses are painted with light colors from outside?
Sir, because so that the rays of the sun,
Mm.
it reflects the white houses, so that inside it should be like some a bit cool. The
Exactly.
house
So
should
that
become cool.
exactly. In fact, many times people would be painting their roof with the white color, okay, na, so that they can keep the house a bit cooler. That is the thing. So that's why they would be doing so that the most of the sun's heat rays are reflected and the house will be kept cool. Okay, that's the thing. So here we have almost completed the chapter, but one more thing is left, that is about the thermal expansion. Okay, that is about thermal expansion. Okay, so heat has various application, right? Now heat has so many application in our life, right? With the help of heat we are able to prepare our food, right? The food is prepared with this. Heat is necessary to maintain life on earth, right? So many applications are there. One of the application is that with the help of heat we can expand various objects. Okay, like we have learned about thermometers. Now in the thermometers, liquid mercury expands, and after expansion it stops at a particular point in the capillary tube of the thermometer, and wherever it stops you look at it and you get the temperature reading. That's the thing. So there are some applications of it. Why is it that the electrical wires are not hung tightly in the summer seasons, particularly they are left loose like this? Why are they? Or why is it bent? Why the railway tracks are bent? Yeah, Halima, what you saying?
Sir, the electric wires are like because in summer, the metal wires are because the metal wires are expand will expand in the summer.
Although I can understand what you're trying to say, but your voice is not coming clearly. Okay, listen here. The reason why the wires are not uh, why the wires, electrical wires, are not hung tightly, because when things are heated they expand, right? Now when a given object, particularly a metal wire or a piece of metallic object, is heated, upon being heated it expands in size. Suppose if this wire were to be hung very tightly like this, if they were to be hung on the electrical poles very tightly in this manner, so when the summer season will come, so it will try to expand now. It will expand because of the heat. Because of that, it will break. It will break from here. So that's why it is hung a bit loose, so that there will be some space for it to expand. Got it, everyone? If you happen to have travel via railways, particularly let's say Indian railways, so you might have seen that there will be some gaps put between the railway tracks like this. Okay, now you might have observed it, like somewhere there would be a gap that will be left here. Yes, anyone? Have you guys observed this thing? There will be gap in the
Yes,
tracks like this. So are they damaged, or have these gaps been created on purpose?
sir, on purpose.
On purpose, no? Right? Also, it's not like they are just left like that. They are also fitted with some support so that it does not drift away, it does not bend in the other manner. Okay, so why it is done so, let us understand that. So that in the summer season the iron rails, the railway track, okay, no, it is going to expand, right? It is going to expand, so that when it expands it will have some space into which it can expand. Like suppose this is the rail track, so it will expand in this direction and this direction now, right? So suppose if this has some space left over here, so it will be able to expand into that empty space now. It can now expand and the size may increase like this, like it can come over here. But if the space was not left for it, this is how it would look like, a zigzag. And what would happen if the train were to run over this track? There will be derailment, right? Now the train will get derailed. It will come off from the track, and the people may
Yeah.
die because of that. Further, you guys might not have seen the bullock cart anymore, right now. But in villages, they are still still it can be found in the villages, right now. Bullock carts. So the wheel of the bullock cart, there an iron rim is fitted actually. There's an iron rim that is fitted over the wooden wheel. This wheel is made up of wood, and this thing over here, so you're seeing that brownish structure, that is actually the iron rim. What is it? Iron rim. Okay. Now you might wonder,
Yeah.
like, how is this iron rim fitted over it? How is it fitted over it? Hmm?
Yeah.
Do they just hammer it with iron nails, or there's
No.
some other thing is done? Let me explain how it is basically done. Suppose this is the frame of the wheel, like this. That's the frame of the wheel. And over this, I need to place this piece of iron rim. Okay. So first of all, what I'm going to do, I am going to take this iron rim and I'm going to heat it. Upon being heated, it will expand, right? It will expand upon being heated, isn't
Yeah.
it? Then I will
Yes.
place it around it. I will place it around it. So suppose now I have placed it around it like this. But is it tightly fitted? Huh? Is it tightly fitted
No.
on the wheel? It is not
No.
tightly fitted on the wheel now. So now I'm going to pour cold water over it. Upon pouring cold water over it, it will contract and its size will decrease, and it will be tightly fitted over the wooden wheel. Getting the concept, everyone, how it basically is done, how it works? Okay. You can actually look for some videos on the YouTube where you can get to see how actually they do this. Okay, now they would be first of all heating it to intense temperature. They will be heating it making it very hot. Then they will bring it over here, and then they will be pouring cold water over it, and then it will contract. Its size will reduce, and it gets tightly fitted over the wood. Hope that much should have been clear to everyone. Okay, that is the thing. Tell me if there's any question from any of the topics. Otherwise, like, the chapter has been finished.
Also,
Okay. Okay, we are going to do some questions. You guys give me 1 minute. I just need to make some editing here. I need to edit out few things. While tapping, like, there was some error. And then we will do some questions. Okay. So first question, which method of heat transfer does not require a medium to travel?
Sir, radiation.
That's radiation. Good. Next. Yes. Yes, Halima. Yes, Salman. Why does a metal spoon feel hot when placed in a cup of hot tea? Yes, Ayush. Okay. Ayush, please use a headphone. Please use a headphone.
Sure, sir.
Just tell me, why does a metal spoon feel hot when placed in a cup of hot tea? It's a simple question. Water metals, are they good conductors or bad conductors of heat?
Sir, metals are good.
Hmm. Right.
When you like, put it in a cup of hot tea, then from the hot side, it will transfer to the cold side and will feel it hot.
So basically, heat is transferred from the hot tea to the metal spoon through conduction. Through conduction, the heat is transferred to it, no?
Yeah.
And in that manner, it gets heated up. It feels hot. Third question, give one example of heat transfer by convection in everyday life. Convection, remember this.
Sir,
Hmm.
boiling the water.
Boiling the water, indeed, it is the simplest example we have. Good. Why you guys are silent? Salman, tell me, have you not understood the topics we have been doing in the chat class? For some of the classes, I guess you were absent. But you joined that class where we have done convection. Turn your camera on. The fourth question, why do we prefer to wear white or light colored clothes in summer?
Sir, can I?
Okay.
Sir, white or light colored clothes are preferred to wear in summer because it reflects the sun's rays,
Hmm.
and therefore we uh we won't feel that hot.
It reflects most of the
And
sunlight.
yeah, and we feel like
Hmm. So
a
that
bit
is the
cold.
reason. Hmm. Good. Next, how does heat from the sun reaches the earth?
Sir, I didn't understand that.
How does heat from the sun reaches the earth? It is asking, does it reach the earth via conduction, convection, or via radiation? That's the question.
Sir, sun reaches the earth by radiation.
Sun reaches the earth?
No, heat from the sun.
Heat from the sun. Okay, continue. Via radiation.
Yeah.
Okay. Yeah, answer these questions as well.
Sir, Kelvin.
Sir, Kelvin.
Yes. Salman, what about you? Yeah. What is the SI unit of heat? If you guys recall, when I told you about the definition of heat, there I had
Kelvin.
mentioned this thing that it's actually joule, no? You guys tend to forget things. Look here. Here I did told you that the SI unit of heat is joule, no? Look over here. After the class, the PPT, I'm going to share it with you guys after the class. Make sure you write down all the important stuff from it. Okay, and you keep revisiting it once in a while. Okay, so that is Joule. Black surfaces are yes. Look at the options.
So he's good, succeed and good absorb, but radiation.
Says me only.
Good absorber but poor radiator of heat. No. Remember we had the example of radiators, car radiators. Why they are painted black? Because they are good absorbers of heat and good releasers, good radiators of the heat also.
Yes.
They are good at absorbing heat, plus they are good at releasing the heat also. Absorbing and releasing, in both of that, both they are good. Okay,
Yes.
good absorber and good radiator of heat. Radiator basically every object radiates heat now, so they are good radiators. Yeah, C1. That one I'm
30,
expecting everyone to answer. Oh, that is 32. What
32 degree Fahrenheit.
exactly? And what about 212 degree Fahrenheit? It is same as
Uh,
what's the boiling point of water?
100
Water
degrees
100. So 212 degree Fahrenheit or 100 degrees Celsius is same. Okay.
Celsius.
Hmm. Normal temperature of human body.
32 degrees.
What?
34.
What? You guys are not. I told you guys to keep reading the NCERT.
36.
37.
37.
37 degrees Celsius. Okay. B1 skip that. Although, like, if you want to know, Kelvin temperature is used for that, by the way. Okay.
Yeah.
Question number C. The metals which allow heat to pass through them easily are
Conductor.
conductors of heat. Okay. Each of the following is a good conductor of heat.
Copper.
Hold on. Let me just erase all of this. That is copper. Okay. Very good.
Copper.
Next question. The transfer of heat in solids takes place
Sir,
by
conduction.
conduction. Very good.
Conductor.
Good. Next. Best insulator.
Uh,
Be careful with this one. Yeah.
aluminum.
First, start by eliminating the option.
Sir, wool.
Aluminum. That is wool, you are saying.
wool.
Okay. Indeed, it is wool. Right now, like here we
Yeah.
have aluminum. The one of the good.
Aluminum is
It's a
good
conductor,
conductor.
right? Water relatively poor. Okay, now it's a poor insulator, poor conductor. Okay. All right. Glass is also poor conductor, but wool is the poorest conductor. Poorest. So hence that makes it the best insulator. No, best poor conductor. Good. Convection occurs mostly in
Convection. Liquids and gas.
what about others? Everyone have to answer. Don't wait for just one of the student to answer. There's so much of network issue from your side, Ayush. Oh. Salman, what about you?
That is liquid and
For the first one,
Mm-hmm. Yes. Next question, Halima. Yeah, Ayush.
Metals becomes solid and circle
Sir, can I tell the sixth
Yeah,
one?
conduction.
Sir,
yeah.
Conduction.
Anyone can answer. Yeah.
Conduction.
So that is conduction. For the
conduct
previous one, the answer was liquid and gases. Convection
liquid and
occurs
gases.
mostly in liquids and gases. Or together we call liquid and gases fluid. Okay. Yeah. Next question. Heat from the sun reaches us by.
Radiation.
Exactly.
Radiation.
Radiation.
Yeah. Which of the following is not a method of heat transfer?
Reflection.
Exactly. Next.
Sir, conduction.
Con- conduction.
Conduction. Very good. Next.
Sir, convection.
Be careful. The shiny surface of a thermos
Sir,
flask.
radiation.
It is radiation. Very good, Salman. Getting the things. See, there why did I told you that? That is the double layered wall. And here you have got vacuum. That's the stopper. And that is the inner shiny surface.
Sir, your voice is echoing.
For actually one of you, my voice is echoing, and whose mic is on? I think Ayush network issue is not good. So my voice is not reaching to you properly as well. But for others, it should be okay. Please turn your
Yeah.
mic. Please turn it off for today. Ayush, turn off your mic. Yeah. Now it is coming better to everyone.
Yes.
Yes, sir.
Okay. Okay. See. So the inner surface is made shiny. Either it is made up of stainless steel or sometimes like a silver coating can be done on this. Okay. Now we know that when we have evacuated air from the two walls of the container, so it's basically vacuum. So via vacuum, conduction and convection cannot occur. So we have minimized the loss of heat via conduction and convection when there's a vacuum between the two walls of the container. Further, what about radiation? How do we minimize the loss of heat by radiation? We have made the inner surface of the thermos flask shiny, right? So thereby it
Yeah.
prevents the loss of heat via radiation. Okay. Next.
Sir, silver.
Hmm. That is even
Sir,
indeed the
trap
trap
air
here.
is bad
Mhm.
conduction.
Good. Okay. Now state the similarities between the laboratory thermometer and the clinical thermometer and the differences. How are they similar and how are they different?
Sir, they are similar as they both have mercury inside
Mm.
Second,
Yeah.
and they are made of glass
we have
covering.
three kits. So clinical thermometer must link inside. It links between 35 Celsius to 40 to Celsius. It
Mhm.
is used to measure the human body temperature. And
Mhm.
laboratory thermometer don't have a sink. It ranges between it ranges from 10 Celsius to
Minus
100
10.
and minus 10 Celsius to minus 110 Celsius. It is used to measure the temperature of various liquids and used for laboratory purpose.
Okay, okay, hold on there. Okay, good. Yeah, next question. Give two examples each of conductors and insulators of heat. Salman, you answer this. Yeah.
What,
Well,
sir?
next question. Give two examples of conductors and insulators of heat. Yes. Halima,
2 minutes, sir.
answer the second question. We
Sir,
are about to end the
metal,
class. Metals.
like
Specific
silver.
examples. Silver.
silver, copper,
Good. And the
Plastic.
insulators? Plastic is insulator.
insulator, plastic, cotton, wool.
Wood.
Cotton,
Wood.
wool, wood. Good. Okay.
Uh,
The hotness of an object is determined by its
degree Celsius.
what?
Hotness of uh, conduction.
Sir,
Any random answer you're giving, Halima.
sir, the question you are asking is where in the screen?
This one. The hotness of an
Okay.
object is determined its. What is the definition of temperature? The hotness or coldness of an object is determined by its
The
temperature.
temperature.
Its temperature indeed.
Temperature.
Okay. Temperature of boiling water cannot be measured